Welcome back to a new exercise. We continue the series of examples about throwing things from buildings. Now we're going to give objects an initial velocity and see how the equations change. Let's dive right in. A person throws a ball with a speed of 17 meters per second straight upward from the edge of a building. The ball reaches the ground 7 seconds later. Find the height of the building. You know the drill by now. We start with the cartoon, we set our coordinates, we draw our y-axis, we draw the ground, which represents y equals 0. We draw our building, or the edge of the building. And the idea here is that we give this object, it's again a ball, some initial velocity vy0. The ball will go up, will reach the max point somewhere, and it will come all the way down and hit the ground at some point. We know the time that it takes for this whole trip. The ball starts here at some height we can call h. This is in fact the quantity we need to find. We are given this initial velocity, which is upward. This is a positive velocity. The ball will go up, will reach the max point, and then will come all the way down, will pass through the point h, but will continue until it hits the ground at y equals 0. For all this, it takes 7 seconds. Since we have time involved in our exercise, we know that we should use one of the two formulas that involve time, and the fact that we were being asked about the height of the building, it means that we have to use the formula that involves that quantity. So again, we write that the position of the ball along the y-axis will be the initial position, or the initial height, plus the initial velocity on the y-axis times time minus 1/2 gt squared. y0 is a quantity that most of the time we set to 0, but we cannot do that this time because the ball started its motion at this point, at the edge of the building. And this is in fact the quantity we have to find. This is h. So h is the height of the building, and it corresponds to the initial position of the ball. The initial velocity we also have, so we just keep it there, minus 1/2 gt squared. What do we know at this point? So the time is 7 seconds, but the 7 seconds is what happens at this point down here, when y is equal to 0. So when the ball hits the ground, y is equal to 0. So we want to set this to 0. So again, just as before, we want to impose that the position of the ball is y equal to 0. And then we can use t to be equal to 7 seconds. And now we can solve for h. So we pass h to the other side of the equation. We get minus h is vy0t minus 1/2 gt squared. Since we have a minus here on the left, we can cancel that by simply multiplying everything by minus 1. So everything reverses sign. So the positive vy0t becomes negative, and this minus now becomes a plus 1/2 gt squared. And now we can plug our quantities. We have minus v0y, which we know is 17 meters per second. 17 meters per second times the time that we know is 7 seconds plus 1/2, 0.5, times g, which is 9.8 meters per second square, times the time, which again is 7 seconds. Everything square. If we plug these numbers in the calculator, we get minus 17 times 7, that is minus 119, minus 119 meters, plus 0.5 times 9.8 times 7 squared, 240.1. 240.1 meters. And this is minus 119, 121. So we get 121 meters. This is the height of the building. In this exercise, we knew the initial velocity of the ball that was thrown upward, and we also knew the total time that it took for the ball to hit the ground. Since we knew that the time was involved, we used the formula that tells us the height of the object at any given time. And the important steps were, first of all, that the initial height was the height of the building, which is the quantity we're trying to find. And the other step was that for the 7 seconds, so if we want to plug t equals 7 seconds, that means that y here, we have to impose that to be equal to 0, because that is the level of the ground. And from there is just algebra, plugging the numbers and solving properly for h. In the next exercise, we're going to have a situation which has some similarities with the trains that were chasing each other. In this situation, we're going to have a race between two objects that are dropped from the top of a building. So don't miss that.